Alright guys, so today we're going to multiply polynomials. It's sort of like what we did on Monday, but it has a few different things in it as well. The way we're going to start this off is using algebra tiles, and I don't know if you've used algebra tiles before, but there's kind of things that go with each. These long rectangles, these are like our x's, so I'm going to fill in an x in both, and the little squares are like ones. Okay? Now what we're going to do is we're going to kind of multiply this across. We're going to kind of go across this way and this way and this way and multiply by these right here. Okay? So the first one we have is an x times an x. Well, we have to make a new shape, which is just a bigger square. That represents x times x, which is actually x squared. Now we keep continuing to the right. I now have x times 1. Well, I know x times 1 is x, and I know an x is a long rectangle. And then I have another x times 1, which is another long rectangle. So far, so good. Now I'm going to go to the 1 below the x right here, and I'm going to multiply that by x. Well, 1 times x again is x, so I'm going to draw my rectangle. But the next one is going to end up being 1 times 1, which is just a square. And then I have another 1 times 1, which is just a square. Now I'll go to the last one, which looks exactly the same. 1 times x is x. 1 times 1 is 1. 1 times 1 is 1. Now the first box after that says what are the factors, or what they're saying is what are these things when I add them together. Well, I have an x here and I have two 1s, so that's going to be an x plus 2. And I'm going to multiply that by the other one, which is also an x with two 1s, so it's another x plus 2. Now to find the solution to that, I can basically just count up my boxes. I have one big box with x squared, so I'm going to have an x squared in my answer. Now I'm going to look at my x's. I have 1, 2, 3, 4 x boxes, so that's plus 4x. Yes, I know I said x boxes. Now the next one is all the 1s. Well, I have 4 of them, so that's plus 4. Okay. Let's go to the next one because it's a little bit different. Now I still have my long rectangles here, and those are my x's, but those dark boxes mean that that's a -1. So I have -1s on both sides. Let's go ahead and write the factors first. On the first one I have two x's, so I'm going to put 2x. But I have -1 and -1, well that together is -2. The next one is right here. I have 1x and I have 1 minus 1, so x minus 1. Now if we do the same thing we did last time, we can get our answer. Well, first I have x times x, which is a big box for x squared. And I have another x times x, another big box for x squared. But now I have x times -1. So that is going to be a long rectangle, but instead of being open, it's going to be negative, so it's going to be darkened. And then I have another one after that for another x times -1. Now I come over to the other one. I have -1 times x, so that's a long rectangle that's negative. I have another negative x that's a long rectangle that's shaded. But then I have -1 times -1, which gives me a positive 1, and another -1 times -1, which gives me another positive 1. Now to get my answer, I just add those up. So I have 2x squareds, so 2x squared. Then I look at my x's. Well, I have 4 of them, but they're darkened. That means they're negative. So I have minus 4x. And then I have two 1s that are both positive, so plus 2. Now that's just one way to kind of show you how this works. We're not going to use algebra tiles every time, but it is a resort if you need to. So let's go down to some actual examples. Now I'm not going to do every one of these because these are actually pretty repetitious. It's all about distribution, okay? So if I look at the first one, I have 2x minus 3 times x plus 1. So what I'm going to do is I'm going to start by looking at my first parentheses and distribute the first term. So I'm going to have 2x times x and 2x times 1. Well, 2x times x, that's multiplying, so we add our exponents, so I have 2x squared. Now I go to the 2x times positive 1, which just leaves me with 2x. Now I'm going to go to the other term in the first set of parentheses and distribute that. And remember to use the sign that's in front of it. So I'm distributing -3. -3 times x is -3x. And -3 times positive 1 is -3. Now I just need to look to see if there's any like terms I can combine, and I'm finished. So I have x squareds first, and that's the only one, so I have 2x squared. I have an x and another one. So I have positive 2x minus 3x, which is negative 1x, or just negative x. And then all I have at the end is a minus 3, so minus 3. And there's your answer. The good thing is about these, that's all there is to it. You distribute, you combine like terms, okay? Now let's look at number 2. It's 3x minus 4 squared. And if you remember yesterday, the stamp method, that means I'm multiplying 3x minus 4 by itself twice. So I'm going to rewrite this as 3x minus 4 times 3x minus 4. Don't try to come in here and distribute the negative or the exponent over that subtraction sign, because it won't work. 9x squared minus 6 plus 16 is not the answer. So let's start our distribution. First, I'm going to start with 3x times 3x. 3 times 3 is 9. X to the first times x to the first is x squared. Now I go to the last one. 3x times negative 4 would be negative 12x. Now I come to the second term. Negative 4 times 3x is another negative 12x. Then I have negative 4 times negative 4 is positive 16. Now I just need to combine like terms. The only x squared I have is the 9x squared. But I have minus 12x minus 12x, so that's negative 24x. And then all I have here is the plus 16, so plus 16. So you can see the process was the same with different numbers. Just take your time and be careful. Now let's look at number 3. It's another one like number 1. I'm going to go ahead and start distributing. X times x is x squared. X times positive 7 is plus 7x. Come to the next term. Negative 7 times x is negative 7x. And negative 7 times positive 7 is minus 49. Now we combine our like terms. I have x squared, it's the only one. I have positive 7x minus 7x, so those cancel. And then I have just minus 49 at the end. So x squared minus 49. Now number 4 looks a lot worse, but it's really not that bad, guys. You're just going to have to distribute to another term in the second set of parentheses. So I have 2x plus 3 times 3x squared plus 2x minus 5. So let's start with the 2x in the first parentheses and start distributing across. So 2x times 3x squared, 2 times 3 is 6. X to the first times x squared is x to the third. Let's distribute to the next one. 2x times 2x, that's 4. So plus 4. X to the first times x to the first, x squared. Now I go to the last term. 2x times negative 5 is negative 10x. So we finished with the first term in the first set of parentheses. Go to the second. I have 3 times 3x squared. Well, 3 times 3 is 9, so plus 9. And I don't have an x on the one 3, so it's just the x squared from the other. 3 times 2x. 3 times 2 is 6, so plus 6. And the 2 has an x on it, so 6x. And then 3 times negative 5 is negative 15. So yeah, it's a little bit longer, but you just distribute. Take it in small pieces. Now I'm going to combine like terms. The only x cubed I have is 6x cubed. I'm going to go to my x squareds. I have a plus 4x squared plus a 9x squared. 4 plus 9 is 13. But remember, we don't change our exponents on our variables when we're adding, so it's just x squared. Now I have negative 1x plus 6x is negative 4x. And then at the end I have my minus 15. So yeah, it looked a little bit longer, but still the same process. Let's go to the next page. Now again, 5 looks really rough, but it's just we're going to be distributing some extra times. So let's go ahead and start our distribution. I have 2x squared times 5x squared. 2 times 5 gives me 10. And then I have x squared times x squared, which is x to the fourth. Now distribute to the next one. 2x squared times negative 3x. 2 times negative 3 is negative 6. X squared times x to the first, x to the third. And now I distribute to the last term. 2x squared times 2 plus 4x squared. Now we move to the second one. And this could get a little messy because there's going to be lots of lines. I have negative 4x times 5x squared. Negative 4 times 5 is minus 20. X to the first times x squared is x to to the third. Negative 4x times negative 3x. Negative 4 times negative 3 is plus 12. And then x to the first times x to the first is x squared. And then I do the last one. Negative 4x times 2. Negative 4 times 2 is negative 8. And then I have the x from the 4. Now I can do my last one. I have 5 times 5x squared. 5 times 5 is 25. So I have plus 25x squared. I have 5 times negative 3x. 5 times negative 3 is negative 15 with the x. And my last one is 5 times 2, which gives me plus 10. So yeah, I mean, it's kind of a monster when you write it out, but it's just small multiplication problems. So let's go through and combine like terms. The only x to the fourth I have is 10x to the fourth. So I'm going to write that below. Now I have a negative 6x to the third. I have a negative 20x to the third, so I can combine those two. Negative 6 minus 20 gives me negative 26x to the third. I'm going to get rid of that. I have a plus 4x squared, plus 12x squared, plus 25x squared. 25 plus 12 plus 4 gives me plus 41x squared. Get rid of those. I have a negative 8x and a minus 15x. Together that gives me negative 23x. And then here at the end I have my lone number, or I have a 10 here. And I believe that is my only number if I look through. So I'm just going to have plus 10 at the end. So I know that's not fun, guys, and that's a really long answer, but if you'll take your time and go slow, it won't be that big of a deal. So let's go ahead and go to the next one. Now these are just repeats of what we did in the front. It's kind of like looking for a pattern, okay? If you see the looking for a pattern part, I'll use as x's, but look below that, 10 and on use different types of variables, but it doesn't matter, guys. Don't let the variable bother you. So I'm going to look at this first one, number 6. I'm going to distribute. I have x times x, which gives me x squared. I have x times 7, which gives me plus 7x. Then I take my negative 2 times x, get negative 2x. Negative 2 times 7 is negative 14. Now I'm going to combine my like terms. I have only one x squared, so x squared. But then I have plus 7x minus 2x. That's going to be plus 5x. The only number I have by itself is 14. So the answer is x squared plus 5x minus 14. If you kind of look, there is a pattern. We saw it on the front page as well. The first term is always the first two terms multiplied together. The last term is always the last two pieces multiplied together. The x squared, the negative 14. This middle term, the 5x, is always the sum or difference of the last two terms with an x on it. So I had negative 2 plus 7, which gives me positive 5, and I throw an x on there. Now, let's just look at number 9 real quick and see if that works here. So the first term is the x's times x, so x squared. Now I'm going to take these two terms. I have 1 plus 9. That's going to give me positive 10, but I'm going to put an x on it. And then I have 1 times 9 would be plus 9. Now let's see if that's actually the answer. If I do it the other way, I get x squared plus 9x plus 1x plus 9. If we combine those together, it does equal that. Okay? So guys, I'll leave the rest up to you. You can always get them in class on the note key. If you have any questions about that, you need to come let me know. So good luck.